Consider the following code. Int count equals 0 and integer total equals 60. If total divided by count is greater than 3, we're going to execute some code. But what's going to happen when this Boolean is evaluated? Because total is 60, but count is 0. 60 divided by 0. A runtime error will occur. There's nothing incorrect about the syntax. However, division by 0 when count equals 0 is illegal in math. So this won't cause a compiler error. However, when the code is actually executed, there will be a runtime error because you can't divide by 0. An interesting feature of Boolean conditionals is called short circuit evaluation. This is another way that some code might be skipped. When using the AND or operators, the right-hand side of the comparison will not be evaluated unless necessary. For example, when using the AND operator, both sides of the comparison have to be true. Therefore, if the statement on the left side is false, the computer will not evaluate the code on the right side. If we changed the previous code, we have count is not equal to 0 and total divided by count is greater than 3, count is not equal to 0 is evaluated first. In this case, it's false. Therefore, the rest of the Boolean isn't even looked at all. It's skipped over, as there's no longer a way for the compound Boolean to be true. This avoids the runtime error. When using the OR operator, only one side of the comparison has to be true. Therefore, if the statement on the left side is true, the computer will not evaluate the code on the right side. In the code below, the computer evaluates the first statement, 2 is less than 3, sees that it's true, and then never bothers to check to see if 4 is less than 8. The code here will be executed because only one of the two conditions must be true to run. So since this is true, the computer skips the rest and just runs the code inside the curly braces. Where else might this come in handy? Well, sometimes the statements that are being executed do something. In this example, the variable I is incremented only if the statement is evaluated. So let's go through this line by line. In this case, the computer sees that the first condition is false. Since the AND operator requires that both conditions are true, it does not evaluate the right side of the conditional or execute the code inside the curly braces. The computer skips down to the last line and prints I is 0. If we change the left side of the Boolean expression to a true condition, the right side will now be checked to see if it's true. The computer checks to see if I is less than 1. Since 0 is less than 1, the condition is true. Both sides are now true. Only then is I incremented by 1, and the code in the curly braces is executed. So this line will print out, and then this line prints out, and I is now 1. Recall, if we switch I++ to ++I, the program below will run differently. By using ++I, first the increment occurs, then the condition is tested. In this case, I changes value from 0 to 1. Then 1 is less than 1 is evaluated to be false, and the code in the curly braces is not executed. However, the output is still I is 1, since that was already incremented.